Alright, Dr. Thompson here. I'm going to go through the problems from the MAT146 derivative gateway, the first one you guys took, and just run through them and show you how to do them. So the first function was this, e to the x times sine x, and we're going to differentiate all of these. So this is the product rule because it's e to the x times sine of x. So typically I call them a and b, and remember the product rule is a prime b plus ab prime. You can do it in the other order, but just make sure that you differentiate one, not the other, and then do the opposite and add those. So e to the x's derivative is e to the x, so it doesn't look like you did much there. Sine of x stays, and of course a was e to the x, but sine of x has derivative cosine x. And that's it for problem 1. For problem 2, this is g of x equals cosine of ln of x. So this is the chain rule. The difference between this and the first one is that cosine and logarithm have to have an argument. They have to have something that they are of, ln of x, cosine of x. So here it's not a product, even though we're using parentheses. It's cosine of ln of x. So that's the chain rule, not the product rule. So the derivative is going to be negative sine, that's the derivative of cosine, ln of x, what's in here stays here, and then the chain rule says take the derivative of the thing inside, which is ln x, and its derivative is 1 over x. So that is the final answer for number 2. For number 3, this was h of x equals arctan of 2x, and this is a double chain rule, or excuse me, a chain rule, but the more important point was just whether or not you remembered the derivative of arctangent, which is 1 over 1 plus x squared, but in this case, x is really 2x. So it's what's inside squared. And then chain rule isn't the chain of the stuff I just wrote, it's the chain of what I circled up there of 2x. And the derivative of 2x is 2. And you can leave it like that, no need to simplify or anything. So that is h prime of x. Okay, so that was number 3. Number 4, j of x was x squared minus 1 over 3. This was just to remind you if you could do basic derivatives. And I have it all over 3. The simplest way to do it, though, is to write it like this. 1/3 x squared minus 1/3. So you don't need to do a quotient rule or anything. You just need to use the power rule and the constant rule. So the 1/3, besides the x squared, is going to stay there. This becomes 2x, and the constant by itself becomes 0. So you just end up with 2/3 x for number 4. Number 5 was also a bit of a trick. This is k of x equals tangent of arctangent x, and you can work this out if you want, but it's a little easier if you simplify first. This is really just x because those are inverse functions, so the derivative is the constant 1. Now that doesn't quite work on 6, which was m of x equals arcsine of arccosine of x. So I'm asking you to remember both those derivatives, and it's a little messy here. Arcsine is derivative equal to 1 over the square root of 1 minus x squared, but now x is arccosine x. So I'm going to put arccosine squared x like that. But then the chain is the derivative of arccosine, which is negative square root 1 minus x squared. Alright, so that is that wonky derivative for number 6. Okay, so when we get to number 7 and 8, this is mostly seen if you remember rules we learned last semester that we haven't used for a while. This was x squared times 2 to the x. And so that derivative is a product rule again. X squared becomes 2x. But then the question is, what happens to 2 to the x? Well, it's very similar to e to the x. Remember, e to the x, nothing happens. Here, it's 2 to the x, but you multiply by ln of the base. You always do that. It's just that ln of e is 1, so that's why we don't write that when we do e to the x. Alright, so that's number 7. Number 8 is similar. This is p of x equals log base 5 of x squared. I'll do this 2 different ways, but the more important point is the log base 5. So remember that for something other than ln of x, it's 1 over what's inside times ln of the base down below. So that goes under the fraction, whereas it was above for 2 to the x. Then the chain rule says multiply by 2 to the x. Excuse me, 2x. And of course, I can cancel this, and so the reason why I want to point that out is because I also could have started by using logarithm rules and pulling the 2 out of the power of x inside the logarithm argument. So if I did it this way, the 2 would be up front, and then you'd have 1 over, let me back up. That 2 is gone, right, because I pulled it out front. And so I would have 2 times 1 over x times ln 5, which is the same thing I have up here. You can either do the chain rule or you can pull the 2 out to begin with. Alright, so number 9, q of x equals arctan x over tangent x. So this is the first time we've had to use the quotient rule. I know it looks like something should cancel, but it doesn't. They're 2 different functions. So remember, this is low times d high minus high times d low. So I'll think of tangent as 1 over cosine squared x for its derivative, just because I'm out of space. You could also have written times secant squared. That's all over low squared. And away we go. Maybe that simplifies, but I would not waste your time. I would just stop there. And then the last one, y of x equals e to the sine of ln of x. This is a double chain rule. And what's confusing typically about this one is that you have to remember that e's derivative is itself. So when it's at the front of a chain rule, it's going to look like you wrote the same thing again, because you did. But then now that is actually the derivative of e, and so of e to the x. And so now we're going to go inside, and we're going to take the derivative of sine of ln of x, which is cosine of ln of x times 1 over x. And that is how you finish that problem. Alright, so there's the 10 from the first gateway. Just let me know if you guys have more questions.